Good afternoon, everybody. We're starting the second session for today. We hope you enjoy it. So give it up for the wonderful Darlene Hibbs from Tripwire.
Hello, and welcome to my talk. And you thought Java was Oracle's biggest security blunder? So who am I? My name's Darlene Hibbs, and I work on Tripwire's vulnerability and security research team, more commonly known as Vert. I'm from Canada, and this is my first time visiting Portugal, so thank you very much for having me. Some of my hobbies include reading, binge-watching TV shows, and streaming video games on Twitch. Primarily, I stream Final Fantasy XIV. So what does Vert do, and more importantly, what do I do as a member of Vert? So we work on a product called IP360, and what it does is it scans an entire network, and it'll tell you what, it identifies all the hosts that exist on that network, it'll tell you what applications that they're running, and it'll tell you what vulnerabilities exist on those hosts. So when I say vulnerabilities, I'm not talking about malware. That was the previous talk. So this is kind of the vulnerabilities that the malware tries to exploit. So specifically what I do on Vert, I'm gonna tell you a little project that I worked on when I first started working about 5 years ago, and it sort of gives a little bit of an introduction to my talk. So when I first started working, I was asked to develop our Oracle database coverage. So this would be so we could detect if an application of Oracle database was installed and what vulnerabilities existed on it. So this included covering every application from 9i through 11g. At the time, 12c did not exist yet, but that's the current version. To cover every vulnerability that existed since July 2005. And once that was all done, to add automation for it so we could add new coverage really quickly. So some common resources that we use to add this coverage are registry keys, obviously on Windows, looking at file versions, and the contents of files. So for various reasons, none of these were really great options when doing our Oracle coverage. So we had to kind of look for a new solution. So I started looking into the oracle.exe file. Now you can see here that it has a file version of 11.2.0.2. That's great for application detection, but if we want to know which patches are installed on it, that doesn't give us very much information. If we look over at the date modified, so this one says it's March 18th, 2012, so that gives us a little bit more information. We know that it has all the vulnerabilities covered before that point. However, unfortunately, once you install this patch, there's no guarantee that that modified date stays the same. It might get updated to when you installed the patch instead of when the patch was created. So I had to start looking into the oracle.exe file. So within it, it contains a header, and it has a timestamp in it. And in the header, it looks something like this. And the timestamp exists right here. So we needed a way to dig this out. But if you convert this number to, or this hex code, to a decimal number, you get this big long number. And when you convert that into a date, you get that it was created on March 16th, 2012. So this is the date that the exe file was compiled. This exists inside the oracle.exe file, so it's never going to change no matter what you do with that system. So what we can do now is we can look at the oracle.exe file on a host. We can grab the timestamp from it. Then we're going to grab the timestamp from an oracle.exe file of a patch, and we're going to compare those two numbers. If the timestamp that's on the host is earlier or the same as the timestamp in a patch, we know that any vulnerabilities covered by that patch are covered on that host. So that's a little introduction to what I do. So for this talk, we're going to talk a little bit about the research that I did into Oracle Database Express. And so to do that, we're going to look at a case study. So this is kind of a fictional account that's based on what actually happened that sort of led me to start this research. We're going to talk about the research process that I went through. We're going to look into exploiting a vulnerability, and we're going to do a little demo. We're going to talk about the conclusion of my research, some additional findings, and then some takeaways that you should get from this. Some things to note. Okay, so Oracle Database Express is the free database offering from Oracle. And some things to note while you're watching this presentation is we're focusing on Windows here. So you can install Oracle Database and Oracle Database Express on Linux, but for the purposes of my presentation, my research focused on Windows because that's where the issue was discovered, and so it has we have some better examples on Windows, so that's what I'm focusing on. And also to keep in mind that while our talk is about Oracle and we're looking at an Oracle product, this exists for numerous different vendors. And so it's something to keep in mind when you're using free products from any of the enterprise vendors and any free products at all. All right, so our case study. So we need a fictional company, and I decided that I was going to call it The Company. And this is because I've been watching a lot of Prison Break lately. So for anyone who doesn't know, the overall antagonist of Prison Break is an entity called The Company. So that's where that name comes from. So The Company is an enterprise-level business. It has many, many employees, hundreds, thousands. And they work on different teams. We're going to look at 2 different teams in specific and 2 employees that work on those teams. So our first employee is Aubrey, and she works on the IT security team. And her primary role is working with IP360. So she runs scans of the corporate network, she identifies the vulnerable hosts on it, and works to mitigate those issues to get the least amount of vulnerabilities in their system. The second person is Sandra, and she works on the database team. And primarily, she uses Oracle databases. So this is what a scan result looks like. Initially, when you run Tripwire IP360. So in this case, we've only scanned 3 hosts, but a host for an entire company might include hundreds or even thousands of hosts. So we're going to be looking at this top one, which for simplicity, we're going to call host.101. And if you look over on the far side, you can see that it has a score of 41,770. It's in red because that's kind of a high score. That means there's a lot of vulnerabilities on this, or that there's some very severe vulnerabilities. So when Aubrey is looking at this, she's like, hey, this is a big deal. We want to get rid of as many of these vulnerabilities as we can. So she's going to click on the link, and then she's going to get a list of the specific vulnerabilities that exist on this host. So if we look at the top one, it's from January 2015, and it's for Oracle. And over here, we have a CVE for it. So for anyone who doesn't know, the CVE is just a way to identify specific vulnerabilities. So CVE stands for Common Vulnerabilities and Exposures. 2014 refers to the year that it was assigned. And then in this case, the additional number is 6567. And if we look at the far side, it tells us the full score for this vulnerability, which in this case is 14,237. So this is more than a quarter of the entire score for the host. So we want to deal with this one specifically to get rid of it, and it'll bring our score down. But if you notice that some of the other vulnerabilities that exist, they're also from Oracle, and they're from earlier years. So October 2012, January 2011, October 2010. So if we install the latest patch for Oracle, it's going to get rid of all these Oracle-related vulnerabilities. It's going to bring the score of that host way down. So Aubrey sends off an email to Sandra, who owns this host, and she says, we have discovered an unpatched version of Oracle Database on one of your hosts, .101. Please install the latest patches ASAP and confirm with us when this is completed. So Sandra uses Oracle databases a lot, so she goes straight to that host, and she fires up SQL+. When she logs in, it tells her that she's running database 11G Express. And just to make sure that that's the version, she's going to run select star from $version, and it's going to confirm that, yes, she's running Oracle database 11G Express. So now that she knows the version she's running, she can go look for patches for it. So she goes to the vendor advisory, which is usually called the Oracle CPU, which stands for Critical Patch Updates. And she's going to go down to this link, which is going to take her to the list of all the patches that are available for databases for this advisory. When she clicks that link, it takes her to a login page, because to install patches on Oracle, you need to have an account with them, and you need to pay them a lot of money. But because she works with Oracle databases a lot, she has this, so she's going to log in. It's going to bring her to this page. This is a very long page. So we're going to use some links to get where we need to go a little bit faster. So the first link we're going to click is patch availability for Oracle products. And it's going to take us to this part of the page. We click here for Oracle databases, and it takes us down here. Here you can see a list of all the versions of Oracle database that there are patches for. Now, you might notice that there's none listed for Oracle Database Express. So Sandra goes back to Aubrey and sends her this email. I've looked into upgrading our instance of Oracle Database on host.101. However, we are running Oracle Database Express, which isn't listed as vulnerable on the Oracle critical patch update pages, and there are no patches available. So Sandra goes back and looks at the scan logs, and she determines, hey, our scan discovered that Oracle 11g Database Release 2 is running on that host. Please provide proof that it's not installed, and we'll file a false positive report with our scan vendor. Scan vendors being Tripwire. So she gets the information she requested from Sandra, and she fires off an email to Tripwire support. We would like to report a false positive for Oracle database vulnerabilities. The host is running Oracle Database 11g Express and is being detected as Oracle 11g Database Release 2. The vulnerabilities detected apply to 11g Release 2 and not to Oracle Database Express. Express is not listed as vulnerable by Oracle in their critical patch updates, and no patches are available. Please see attached files. So the attached files are a screenshot of program and features, which shows that Oracle Database 11g Express is installed, and a screenshot from our scan log, which shows the vulnerability that was detected, the host that it was on, and the application that the vulnerability was bound to. So this is the point where it kind of comes to me, and I'm asked to investigate if this is a real false positive, if the customer's claims are correct, and if we need to make any changes. So to get started, we need to ask a couple of questions. So the first question is, why was Oracle Database 11g Express detected as Database 11g Release 2? The second question, and probably the most important that we need to ask, is Oracle Database Express vulnerable? And if it is, why isn't it mentioned in the Oracle advisories or the CPUs? So going into this research, we have a bit of knowledge. So I'm going to share that with you so you know the starting point. So we know that Express is the free edition of Oracle's database offerings, and some other editions include Standard and Enterprise. Our coverage at Tripwire detects versions and not editions. So Oracle 11g Database Release 2 can refer to any version that starts with 11.2. And we also know that Oracle releases patches for their supported databases 4 times a year. So these come out in January, April, June, and October. And we know that Oracle Database Express was released in September 2011. So the first thing we need to know is what version is Express 11g an edition of. So if we go to their download page, it says right here that the database is based on Oracle Database 11g Release 2. So that's what we detected on. So our application detection was correct. Just to double check though, after we installed an Oracle Database Express environment, we can run SQL Plus and we can see that specifically it's running 11.2.0.2. So now we kind of want to look to see what vulnerabilities exist for it. So we're going to start with a simple Google search. So the search is for Oracle Database Express vulnerabilities. Now the first two aren't really relevant for what we're looking for. They're just a list of all the CVEs that exist for Oracle Database as a whole. But we want to know about Express specifically. So we're going to look at vendor advisories, which we already saw a little bit of. But we're going to look at all of the ones that exist since Oracle Express Database was released, and to see what kind of mention of Express is in them. The other thing we're going to look at is product support forums. So we're going to see what kind of questions other users of Oracle Database Express have been looking for and what kind of answers they've been getting. So our first look is at the vendor advisories. Now, we saw the top of the CPU page earlier, but if you scroll way down on it, you start to get into these tables. And so this is the table for Oracle Database. And it lists 7 CVEs. So there's 7 vulnerabilities in this advisory that exist. So the CVEs are listed down the side, and next to it shows the components that are affected by each CVE. And over here, we can see what supported versions are affected. So it's important to note here that it's talking about supported versions. It's not saying these are all the versions of Oracle that are vulnerable. It's just saying these are the ones that we are currently supporting that are affected. So you can see on the top line, hopefully, that the first version is 11.2.0.4. So it has the same major version, 11.2, but our Express was running 11.2.0.2. So that tells us that it's probably still vulnerable because it's in the same major version. It's just not supported anymore. So there aren't actually any patches for it. But we can look at some other advisories. So this is from a different month, and there are 4 different CVEs for it. And this one has 5, this one has 4, this one has 2. We're not going to look at all of them because there's 18 advisories in total since 2011. These 18 advisories cover 107 vulnerabilities. And in all 18 of those advisories, there is no mention at all of Oracle Database Express. So we're going to move on and look at some vendor support forums. So here we're going to look at what kind of questions people are asking about vulnerabilities and Oracle Express. So this question was, can I install an Oracle patch on Express 11G? XE is the short form for Express. Another question was about applying critical patch updates on Express. Express and security patches, a specific vulnerability, TNS poison on Express, bundled patches and patch set upgrades for Express, and can they be installed on Express? And then another question asking about a specific vulnerability. So the summary of all those questions was that nobody was asking if Express was vulnerable. They were just asking how to resolve the vulnerabilities that they already knew existed. So this leads us to a pretty good conclusion that Express is vulnerable. It also sounded like a lot of the users were expecting there to be patches and updates. They were expecting to be able to resolve the security issues on their Express install. But some people knew that they weren't going to find patches and updates for Express, and they were simply trying to install patches from different editions. So if you remember, Express is edition, Standard is also edition, Enterprise is edition. They have patches for them, and people were trying to install those patches on the Express version. And they were also asking how they could be secure without having to change products. They're already using Database Express. They don't want to have to upgrade. They don't want to have to install a different product. All of that requires work. There were answers to all these questions, or most of them. And they were mostly by a single person who was an Oracle employee. And these answers consisted of, Express cannot be legally patched. Patches are not available for the Express edition. No, Express cannot be patched. Please reread the license agreement. And so on and so on. Express is not patchable. There is no support available. So now we know that it is vulnerable and there are no patches for it, which leads us to believe that our detection, where we detected that Express was vulnerable, is correct. But we're going to go look a little bit deeper. So what does the license agreement actually say? One of the answers said to go look a little bit deeper into it. So this is the no technical support section from the license agreement for Oracle Database Express. So specifically it says, our technical support organization will not provide technical support, phone support, or updates for you for the programs licensed under this agreement. That's for 107 vulnerabilities. You're getting no support for, no updates, no security patches. All right, so that was actually a little bit of an exaggeration, because if you look a little bit deeper, Express is not a full database installation. So there's certain components that exist in the full versions of the database that aren't going to exist in Express, and there's 48 CVEs that affect those. So we can say that of those 107 vulnerabilities, there's 48 that we just don't need to worry about because they don't exist on Express. In addition, there's 9 optional or unconfirmed. So optional means they don't install by default on Express, but you might be able to install them additionally. And unconfirmed just means we don't have any specific information about it. We don't really know because there's not enough information. That leaves us with 50 vulnerabilities total. So that's 50 vulnerabilities, 50 ways an attacker could attack your database. Now, this is all kind of theoretical knowledge. So we've done a lot of research. We're pretty sure that it's vulnerable, but how can we actually confirm that it's vulnerable? So we're actually going to try to exploit one of these vulnerabilities, because 50 would be too much, on a database express. So the one that we're going to look at is CVE 2012-1675, which exists in the listener component. So now we're going to ask the more specific question of, is Oracle Express vulnerable to CVE 2012-1675? Before we do that, though, I'm going to give a little history of this CVE, because it's kind of got a bit of an interesting story. So it has a name, which is the TNS listener poison attack. It kind of made a lot of media and news, so a lot of people are aware of this one, and people know it by the TNS listener poison attack name more than the CVE. It was discovered in 2008 by Joxian Correa, whose name I'm probably butchering, and I apologize to him. You might note that the CVE was released in 2012, which is 4 years after it was discovered in 2008. But it likely existed since 1999. That was when the feature that is being exploited by this vulnerability came into existence, when it was first introduced in Oracle. So after Mr. Correa discovered this vulnerability, he went and he reported his findings to Oracle, where they left it unpatched for 4 years, for a total of 13 years since it started existing. Now, in April 2012, they released a CPU that thanked Mr. Correa for his contributions to Oracle's Security in Depth program. And this came out on April 17th, 2012. So after the CPU was released, Mr. Correa assumed it had been patched. He realized that now I can release my findings. He's going to release all his research so everyone knows all the details of it, and then they can have the patch that was released the day before. So on April 18th, he releases his research publicly. Unfortunately, after it was released, it was determined that it wasn't actually patched in the current releases. Oracle had thanked him because they had patched it in their current release, which was 12C at the time. So they patched it in their newest version, but they didn't backport the patch to the previous ones, leaving anything prior to 12C completely vulnerable to a vulnerability that now has all the information about it out in the public. It took them until April 30th, 2012 to release a security advisory that explained to their customers how they could protect themselves against this vulnerability. Now, this one is a little bit different than most vulnerabilities because there's not actually a patch for it. So users have to go in and apply what we call a workaround to it. So on this page, it gives us a couple different options. So one, you can restrict registration via the TCP protocol, or you can restrict it via the IPC protocol. Now, we're going to do some little demos on how this works, so you'll understand this a little bit more later. But we're going to use the second option. Now, the reason I'm picking this one is because the first option actually requires another bug fix, so you have to install another patch. To make things easier, we're going to go with the IPC protocol, which we can apply without any fixes. So the steps that you need to do, first of all, you need to stop the listener, and then you need to update the listener.aura file. Now, for the IPC fix to work, you need to ensure that you're using IPC, so it should have a line that looks something like this. And then the fix is actually this bottom line. So secure register listener prod. Now, the listener prod part refers to the name of the listener, which is up here. So when we do our demo later, it's important to note that our listener is actually just called listener. So our fix line is going to be secure register listener equals IPC. And then we're going to restart the listener, and hopefully we are protected from this vulnerability. So, 1 second. So we're going to talk about how this attack works. But before we do that, I want to give you guys a little overview of how the listener actually works. So what it does, basically, is it sets up a connection between the client and the requested database. So we have a client, we have a listener, and we have the local database. Now, it's local because it exists on the same system as the listener. And the name of our local database is Oracle 11. So the local database registers itself to the listener. Now the listener knows where that database exists. If it gets a request from the client, it knows where to send them off. So the client's making a request for the database Oracle 11. The listener tells them about the one it knows about because it's locally registered, and then the client and the database can communicate. Now you can also register remote databases. So in this case, we're going to register a remote database called DB11. It's important to note that you don't need any authentication to register remotely. You just have to say, hey, I have database 11, I'm over here, please tell people to connect to me. So now if the client requests database 11 from the listener, it's going to send it to the remote database and it can communicate. So how exactly does this vulnerability work? So we have our same setup. We have the client, we have the listener, we have the local and remote database. What if we got rid of the remote database, though? And what if we replaced it with a fake database or an attacker's database, which is not actually a real database? It's just going to register with the listener and tell it that it is. You might also note that our fake database now has the same name as the local one, so Oracle 11. Now when the client makes a request to the listener for database Oracle 11, the listener has a choice. It's going to decide whether it sends it to the local database or to our remote fake database. And there's about a 50-50 chance which one it's going to send it to. So in our case, our listener tells the client about the remote database. So now the client is going to connect to it. At this point, we can perform what we call a man-in-the-middle attack. So the fake database doesn't have any actual database information on it, so it's just going to send off that information to the local database. Now the client thinks it's communicating with the local database, and the local database is communicating with the client. However, all the information is going through the fake database. The attacker who set that up can track all the information that's being passed across it. We can go a little bit further, and now we can do a session hijack. So if we kind of nuke the connection between the client and the fake database, so your fake database is going to sever this connection, now it can continue to talk to the local database as if it were the client. So anything that the client was able to do, read the database, change the database, possibly even delete the database, now your attacker has full access to do that. So now we're going to do a little bit of a demo. And I have some videos for that. So we're going to be running this on a virtual machine. And so when we see a black command line, it's going to be within the virtual machine. There's actually a second command prompt that's going to pop up. It's going to be in red. This is our attacker's command line, and it's existing on a different system. So I was running it on the local system and attacking into a virtual machine. So we're going to open up a command prompt, and we're going to run lsnr ctl, which is the listener control. And then we're going to run a status command. So you can see down here that there's a bunch of services registered. That's the part we want to pay attention to. So now we're to our command, or our attacker's command line, and we're going to run a proof of concept against it. So just to pause for a second. So to run the proof of concept, we just need to give it our address, so that's the local attacker's machine, our port, which can be any port, so we're just going to use 123, the service name, so that's the name of the database that you want to register, the target address is going to be the VM that we're attacking, and the target port, the listener runs by default on 1521, that's what ours is listening on, so that's the port we're going to put in. So now you can see the local IP is .1, the host is 1234. We're going to call our database SINFO1, and we're going to attack host.104 on port 1521. So you can see that we get a lot of information back from that. And if we go back over to our host and run status again, we can see that the SINFO1, I'm going to pause that for a second. I hope you guys can see that. You can see that SINFO1 database was registered. So we're going to go back here again, and this time we're going to register the database name Oracle 11. So that was one that was already running on the host, so you can see what happens when we do that. So we're going to change SINFO1 to Oracle 11, and we're going to run that again. So again, we get a whole bunch of data back from the host, and if we check over here, then we can see that now there's 2 instances of Oracle 11 registered. At this point, we're going to stop the database because we're actually going to apply the workaround or the fix for this vulnerability. So if we open up here, this is our Oracle home directory, and if we scroll down, we're going to go to the network directory. In there, the admin directory, and then we can open the listener.ora file. So you can see in here that we have the protocol equals IPC, so we just have to add the one line to fix this problem. So secure underscore register underscore listener equals IPC. At this point, we can save this file, and we can go back to our listener. So we're going to open up our listener control again. And we're going to start up the database, or sorry, start up the listener. And then we're going to go back and we're going to run our attack again. So now it shouldn't work. So running it again, now we're not getting a whole bunch of data back like we were before. And if we go over and check with a status command in the listener, it's going to show us that it didn't actually register that. So it's now rejecting our attempt to register to the listener, so we've protected ourselves against this attack. So now this was run on just a regular Oracle database installation that we know is vulnerable. So now we're going to run it against Oracle Database Express just to ensure that it is actually vulnerable on Express. So we can see here that Express is installed, but just to double check, we're going to go in and open up SQL+. And we're going to log in. And it tells us we're running Oracle Database 11G Express. Again, just to double check, we're going to run select star from $version, which is also going to tell us that we're running Database 11G Express. So now we can exit out of SQL Plus and start up the listener control. And if we run a status command against it, we see all the same information as before. So now we're going to go back to our attacker's prompt, and we're going to run the proof of concept again. So we're going to put in our local host IP, which is still .1, a random port 123. We're going to call our database SINFO1 again, and we're going to run it against the .101 host. And that's running on port 1521 still. So now we got an answer back. So that gives us a pretty good idea that it worked, but we're going to run a status, and now you can see that SINFO1 was registered. Now, because this isn't a patch and it's actually a workaround, we can still apply it to Oracle Database Express. So this is one of the few vulnerabilities that you can actually solve if you're running Oracle Database Express. So we're going to go back into the listener.ora file, and we're going to add that exact same line that we did before. So secure register listener equals IPC. And we can close everything down, and we're going to go back to our listener control. And we're going to start it back up. So it started back up. Let's try exploiting it. We're going to run the same command against it. We're going to try to register SINFO1. Now it's being blocked. And if we double check in here with another status command, it wasn't registered. So we know that Oracle Database Express is definitely vulnerable to this issue, but we also know that there's a fix for it. But that's only because it's not a patch. If it was a patch, we wouldn't be able to solve this issue at all. So that kind of brought me to the end of my research for this specific issue. So we now have answers for all those questions that we asked at the beginning. Why was Express detected as Oracle 11G database release 2? It's because it's an addition of that. So that was a correct identification. Is Oracle Database Express vulnerable? Yes, it definitely is. And why isn't it mentioned in the Oracle CPUs? Well, because Express is unsupported, and they only release their advisories for supported products, where they're actually giving fixes for them. So we know that there's no fixes for Express. That's why it doesn't exist in the advisories. So after this conclusion, our support team fired back an email to Aubrey, who works at the company, and she says, our research team has investigated your false positive report for Oracle Database Express and has closed it as invalid. They concluded that while there are no patches available, it is due to Oracle not offering any updates or patches for the software, and Oracle Database 11G Express was built from the same code as Oracle 11G Database Release 2. The application and vulnerability detected in your scan are valid. That's not quite where we stopped though. So we didn't fix the issue that the customer was having because we determined that it wasn't an issue. However, we did learn some interesting things about Oracle Database Express. So we added a separate Express application coverage. So now if someone's running the addition of Express, we will fire a vulnerability that says that that is what you're running. Now we use that coverage to determine, if you remember there was 48 CVEs that don't exist on Express, so now we don't fire those vulnerabilities on a host. So a customer who's running Express won't see those 48 vulnerabilities, whereas if they were running a full database, they would. And in addition, I wrote a blog post. So now if you do that same Google search that we did at the beginning, Oracle Database Express vulnerabilities, the first result is my blog post, which has the same name as the title of this talk. So after I did all my research, I had a little bit more questions. I was kind of wondering, well, why does anyone use Express if it's so vulnerable? Well, Oracle says it's a great starter database for developers working on Node.js, Python, etc., DBAs who need a free starter database for training and deployment, independent software vendors and hardware vendors who want a starter database to distribute, and educational institutions and students who need a free database for their curriculum. But I wanted to look a little bit deeper as to what you actually were allowed to do with Oracle Database Express. So I started digging into their actual license. Now, little disclaimer, I'm not a lawyer. This is simply my interpretation of their license. I've seen some other interpretations that are quite different than mine, so if you are going to use it, you might want to consult with a lawyer. And please don't take my word for it. But from what I can understand, the things that you're allowed to do with Oracle Database Express are you can develop with it, prototype, you can run your applications on it, you can distribute their program, you can use it for demonstrations and training, and you can copy and distribute it. However, if you Google Oracle database downloads, it brings you to this page. Now you might see on it that it's for Oracle Database 12c Release 1, and it's for the Enterprise Edition. You might also note that this page doesn't require a login. So you can access all these downloads for the full Enterprise Edition, or if I could show more of this page, the Standard Edition links are below. So you can download their full products without having a support contract with them. So you don't have to pay Oracle any money. You can still use these products for free. Now, then the question is, well, what are you allowed to do with those products if you don't pay Oracle any money? So if you look into their license, the standard license says that you're allowed to use it for developing, testing, prototyping, and demonstrating. So it's a little bit of a shorter list than Express, but there is still some things that we can use an Oracle database for, even if we're not using their free version, but while we're still using it for free. So a side-by-side comparison of Express and Standard, the things that you can do in both, developing, prototyping, demonstrating, training, you can do in both Express and Standard. Where it differs is down in running a production environment or distributing it. Now you have to remember though, that you're now running an environment that has no patches for it. So you have tons of security vulnerabilities. So you probably want to think twice before running it in a production environment, and before distributing it to other people. So we're going to take a step back and look at the technical support. So we already looked at the express statement. Now, this is again from their license. So just to reiterate, there's no technical support. Our technical support organization will not provide technical support, phone support, updates for the programs licensed under this agreement. Now, what exactly does this the standard license say about this? It's a little bit longer, but it also says there's no technical support. Now, this is if you're using it as a free product. So unless Oracle support for the programs, if any, is expressly included in a separate current support agreement between you and Oracle, which means you give them a lot of money, Oracle's technical support organization will not provide technical support, phone support, or updates for you and your programs provided under this agreement. So you basically get the same level of support using their full database as you do with the express version if you're using it for free. So we can expand our side-by-side comparison to include a line about updates and patches. So in Express, they don't exist, not at all. In Standard, though, they also don't exist if you're using it for free. However, you do have the option at any time to start paying for it when you finally need security updates. So my conclusion on when you should use Oracle Database Express is very limited. You should only use it if you must use Oracle, because there are other free and patchable database. An example is Postgres. So if you need a free database, there's definitely still options out there that you can still get security updates for. You also should only use it if you never need a larger database, because there are limits to the size and the hardware that you can run Oracle Express on that doesn't exist in their bigger in their standard and enterprise versions. And when you do need the larger databases, you won't need to migrate it if you're already using the standard or enterprise version. You also should only use it if you don't need confidentiality, integrity, and availability. And what these specifically means is confidentiality means you don't need that there's no unauthorized access to the data. So you don't need to assure anyone that their personal data is kept private, that their financial data is kept private, or that their medical data is kept private, that you're not storing any of this information, and all the information you're storing on your database, you wouldn't mind if anyone looked at it. Integrity means you know that your database has the correct information in it, that nobody has tampered with it. And availability means that it's always accessible. So if you don't care that your database is available 24/7, it can go down for 2 hours, it can go down for a day, it could go down for a week, that's not a big deal, then you can use Oracle Database Express. So is all free software a security risk, though? Obviously not. Free software can be great, even if you need security updates. There are tons of open source products that are great, that update frequently, that give you security patches. You just have to ensure when you're using a free product that it doesn't mean that it's very vulnerable. You have to make sure that it's still a secure product, that you're not introducing tons of vectors into your database or whatever you're using that could allow hackers to attack you. Because patches and security updates are very important, and we want to make sure that anything that we're running, that you have the ability to add security updates to them. And that's the end of my presentation. Thank you very much, and please let me know if you have any questions.
Thank you, everybody. Any questions? Anyone? No? No questions? Oh.
Isn't it bad for the attacker to use its own IP address to make the attack on the database?
Obviously, yeah. In this example, we're using it, so if you were running like a sniffer or you were looking at the logs on the host, you could see exactly where that attack was coming from. The attack in my example wasn't an actual attack. It was the proof of concept that, that Mr. Correa wrote when he was just proving that this vulnerability existed.
Anyone else?
Are the vulnerabilities of other Oracle databases as noticeable as in the Express version?
Absolutely. So for any Oracle product, all these vulnerabilities exist. But again, for even like Postgres or any other database software you're using, it has a lot of the similar vulnerabilities. All the issues are the same. You can find exploits for all of them. The difference is just how, like, can you protect yourself from those attacks?
Questions? Okay, I think that's it.
Thank you.
Thank you, and give a round of applause to Darlene.